In mathematics, grouped frequency tables are a powerful tool for organizing large datasets, especially when working with continuous data or data with a wide range of values. Unlike simple frequency tables, which list each individual value and its frequency, grouped frequency tables simplify this process by categorizing data into intervals, or groups, allowing for a clearer view of distribution patterns without excessive detail. This approach is particularly helpful for datasets where individual values are less significant than overall trends, or for situations where listing every unique value would be impractical, such as analyzing heights, test scores, or ages in a large group. To create a grouped frequency table, we start by deciding on suitable intervals that cover the full range of values in the dataset. Each interval should be of equal width to ensure consistency and to make the data easier to interpret. For example, if we are examining test scores out of 100, we might group the scores in intervals of 10, such as 0-9, 10-19, 20-29, and so forth, up to the highest observed score. The width of these intervals should be chosen based on the data's spread and the level of detail desired. Intervals that are too broad may obscure important trends, while those that are too narrow may make the table unnecessarily complex. Once the intervals are established, we then tally the frequency for each interval by counting how many values fall within its range. This involves going through the dataset and assigning each value to the appropriate interval, noting each occurrence as we go. The final table lists each interval alongside the frequency, showing at a glance which intervals contain the most or least values. This frequency distribution can reveal patterns in the data, such as where values are concentrated or whether the data is spread out across the intervals. For example, a frequency peak within a particular interval might suggest that most values cluster around a central range, while even frequencies across intervals might indicate a more uniform distribution. Grouped frequency tables also enable us to calculate an estimated mean, which is useful for getting an average value when we cannot or do not need to know each individual figure. To estimate the mean from a grouped frequency table, we use the midpoint of each interval as a representative value for that interval. This midpoint is simply the average of the lower and upper bounds of the interval. For example, if the interval is 10 to 19, the midpoint would be 14.5. We then multiply each interval's midpoint by its frequency to obtain a weighted total, reflecting the contribution of each interval to the overall dataset. Adding these products together and then dividing by the total frequency gives an estimated mean, which represents the average value across the dataset with reasonable accuracy. In addition to the mean, grouped frequency tables can also help in estimating other statistical measures, such as the median and the mode, although these will also be approximate. To find the estimated median, we first determine the cumulative frequency for each interval, which is the running total of frequencies up to and including each interval. We then use this cumulative frequency to identify the interval where the median lies by finding the position of the middle value in the dataset, based on the total frequency. Once the interval containing the median is identified, we can use an interpolation method to estimate the precise median within that interval. Similarly, the mode can be estimated by finding the modal class, or the interval with the highest frequency, and using an approximation technique to determine the likely mode within that class. In many cases, grouped frequency tables are presented visually in charts or graphs, such as histograms or frequency polygons, to illustrate the data distribution more vividly. In a histogram, each interval is represented by a bar, whose height reflects its frequency, providing an immediate view of the distribution shape and making it easier to identify trends, clusters, or outliers. Unlike traditional bar charts, there are no gaps between bars in a histogram, as the intervals are continuous and represent a smooth range of values. A frequency polygon, meanwhile, plots points at the midpoints of each interval, connected by straight lines, offering a line-based alternative that can highlight changes in frequency more directly. Grouped frequency tables are an effective way to manage large or continuous datasets, making it easier to identify overall trends, calculate approximate averages, and present information clearly. By organizing values into intervals, these tables offer a simplified yet insightful view of data, allowing us to summarize complex information in a way that reveals key patterns without overwhelming detail. Whether used alone or as the basis for graphs and charts, grouped frequency tables are invaluable for analyzing data in both everyday contexts and more advanced statistical studies.